Hi guys, this video is going to cover that last example we saved from P2a, and then we're going to start getting into P2b. As a reminder, you're going to submit these notes for a grade today, so make sure that when we get to the end, you export them to Canvas. You do not need to include this first example, which is example 6 from yesterday's notes, but you will do the remaining of the P2b notes, so just make sure you're pausing when you need to and make sure you're taking notes so that you can turn it in at the end. All right, so this was example 6, A and B, which I said to skip yesterday, we'd come back to. So the first thing we want to do in each of these is distribute the exponent on the outside. So this 3 is going to go to the 3. That'd be 3 to the third, or 27. And then the 3 goes to the a squared. We raise the power to a power, so this would be a 2 raised to the third power, which is a to the 6th. And the 3 goes to the b there, so that would be b to the third. Then it's multiplication. So you can keep it in parentheses. You can write multiplication next to it, but don't add the plus symbol because this is multiplication. All right, then we go to the next one. 2 to the second, so that's going to become 4. A to the third raised to the second, which would be a to the 6th, and b raised to the second, or b squared. Now we're multiplying these two together. So I'm going to do 27 times 4, which is 108. And then multiplying a to the 6th and a to the 6th would be a to the 12th, because we're going to add the exponents. And then multiplying b to the third and b to the 2nd would be b to the 5th, because again, when we multiply, we're going to add the exponents. Okay, moving into example B. So we're going to distribute. This would be 2 to the 4th. 2 times 2 times 2 times 2, which is 16. X to the 2nd raised to the 4th, so we're going to multiply those. That would be x to the 8th. Y to the 3rd raised to the 4th. Again, multiply the exponent, so this is y to the 12th. And again, multiplication. Then a negative raised to the 2nd power. You can either separate that off the x or keep it with it. Either way, it would be in parentheses, so that negative raised to the 2nd power would actually become a positive 1. And then it would be x to the 2nd power, so x squared, and y to the 2nd power raised to the 2nd power, y to the 4th. Then we're multiplying out this step. So 16 would get multiplied by any coefficient there. There's not one there, it's a 1, so that would be 16. X to the 8th times x to the 2nd. Add those exponents, so you get x to the 10th. And y to the 12th and y to the 4th. Add those exponents, you get y to the 16th. All right, moving into P2. This is part 2, so this is actually P2b, which P2 is still exponents and radicals, but what we're going to talk about today is the negative exponents. All right, so negative exponents and dividing with exponents. Exponential expressions with negative exponents move from numerator to denominator or vice versa. So if I have a negative on the exponent in the numerator, it's going to move that term to the bottom, making the exponent positive. And if I have a negative exponent in the bottom, it's going to move that term to the numerator, making it positive. So if I had a to the negative 1, that becomes 1 over a to the n, or sorry, a to the negative n would become 1 over a to the n. And if I had 1 over a to the n, negative n, that would go to the top, and it would become a to the n. So if I had x to the negative 2, that's going to become 1 over x squared. And if I had started with 1 over x to the negative 2, that would become just x squared. So in the numerator, it moves to the denominator. In the denominator, it moves to the numerator. It doesn't impact the base at all, just the exponent on the base. When you're dividing exponential expressions with the same base, you're going to subtract the exponents. So when we multiply, we add. If we divide, we subtract. And you're going to keep it wherever the exponent was larger. So if I had x to the 7th in the top and x to the 2nd in the bottom, you could expand this out, and I could make this x times x times x times x times x times x. I think I got 7 there. Over x times x. And you could cancel them out and be left with x to the 5th. Or, much simpler, is to take the larger exponent and subtract the smaller from it. So 7 minus 2 is 5, and put it wherever the larger exponent was. Because it was in the numerator, this would just be x to the 5th. If it was reversed, if I had x to the 2nd in the top and x to the 7th in the bottom, I still subtract, but this time it would be in the denominator because that's where the larger exponent was. All right, so we're going to work through some examples, and the directions here just say to simplify. By simplify it with negatives, it's implying that you eliminate the negative exponent. So for number 1, that's 4 to the negative 2. I'm going to put that as 1 over 4 to the 2nd power, and then we can go a step further there and make that 1 over 16. X to the negative 3rd would be 1 over x to the 3rd. 2x to the negative 4th. Now this time, only x has the negative 4th on it. If it was in parentheses and the negative 4 was the outside, they would both move. But because that negative 4 is only the exponent on x, the 2 is going to stay where it is, and the x to the 4th would bump to the bottom. Now you have two choices here. I can either distribute the negative to both the top and the bottom, and I'd end up with 2 to the negative 3 over 5 to the negative 3. And then I would move both. So because the 2 has a negative exponent, that would go to the bottom. It would become 2 to the 3rd. And because the 5 has a negative exponent, it would go to the top, and it would become 5 to the 3rd. 5 to the 3rd is 125, and 2 to the 3rd is 8. That's as simple as that one gets. The other way to do it is if the negative's on the outside, we can flip what's on the inside. So it would go 5 over 2, making the exponent on the outside positive. And then you would distribute. 5 to the 3rd would be 125. 2 to the 3rd would be 8. So both ways get you to the right answer. It's up to you which of those methods you choose. All right, 5, negative 4 to the negative 2. So the negative 2 on the exponent says move this to the denominator. So this would become 1 over. Now the 4 and the negative stay together inside the parentheses. And now my exponent becomes a positive 2. It's important that it stays in parentheses. If you lose the parentheses, you'll end up with a negative answer when this should be a positive 1 over 16. So here's different, right? This is negative 4 to the negative 2, and the negative's not with the 4. So the last thing we do is apply the negative. So the negative comes to the outside, and then it would be 4 to the negative 2. So 1 over 4 to the 2nd power, and this becomes negative 1 over 16. All right, some additional examples here. Again, directions just say simplify. So when we look at number 7, x does not have an exponent. The only one that has the exponent is the y to the negative 3. So we're going to move just the y to the denominator. The x stays in the numerator, the y gets bumped to the bottom, and the exponent is now a positive 3. For number 8, you've got your numeric coefficients and then your variables. So looking at just your coefficients first, you want to simplify this. 4 actually goes into 16. So 4 goes in itself once and into 16 4 times. And then with your variables, you've got one in the top and one in the bottom. So we're going to take the larger, which is 4, subtract the smaller from it, which is 3. And that x to the first is going to stay where it was larger, which is the denominator. So what's left here is 1 over 4x. All right, number 9. So you've got 4 that's raised to a positive 1, right? There's no exponent there, which would be a positive 1. The x is raised to the negative 3, y positive 2, z negative 4. So only the ones that have negative exponents are going to move. Everything else is going to stay where it is. So the 4 and the y squared will stay in the top. The x to the third will come to the bottom, and the z to the fourth will come to the bottom. Ten. There's only one coefficient, so the 3 is going to stay where it is. The x has a negative 2, that's going to move. And the y in the bottom has a negative 3, that's going to move. So the first thing I do is rewrite it without the negatives. So the 3 is going to stay. The y to the fourth stays in the top. The x to the fourth stays in the bottom. Now the x to the negative 2 is going to join the denominator. And the y to the negative 3 is going to bump up to the numerator. So everything that had a negative exponent moved. Now I've got 3 in my numerator. Y to the fourth times y to the third. I add my exponents, so I'd get y to the seventh over y to the fourth, and x to the fourth and x to the second. I add the exponents, and I get x to the sixth. Okay, moving into examples 11 through 16. So 11, you've got a 5 to the 9th and a 5 to the 7th. What you don't want to do here is actually find 5 to the 9th and 5 to the 7th and then simplify. You want to simplify because they have the same base. We can simplify first and then raise it to the power later. So because the exponent is higher in the numerator, we're going to subtract. It would be 9 minus 7, which is 2, and we're going to keep that in the numerator where it was larger. 5 squared becomes 25. X to the 14 in the top, x to the 10 in the bottom. We're going to do 14 minus 10, and I get x to the fourth. Thirteen is now the reverse. The x to the 14 is in the bottom, the x to the 10 is in the top. So we're going to subtract, but this time we're going to leave it in the denominator. So it would be 1 over x to the fourth. Fourteen brings back in that negative exponent. So the first thing we're going to do is move that base to the top. So it's 7 to the 5th times 7. It would become a positive 3. And it would be 7 to the 8th. Now, if you had a calculator, you would actually go ahead and raise that to the power, which would be 5,764,801. Without a calculator, which would be on your quiz, you're going to just leave it like that. We don't expect to multiply 7 times itself 8 times. Okay, going to 15. So your coefficients, 5 goes into itself once and 15 3 times. And then the x to the fourth is going to come to the bottom. The x to the 8th is going to come to the top. I get 3x to the 8th over x to the 4th. And then we've got the same base here. So I'm going to subtract the 4 and keep it where it is, larger, which was in the numerator. And I get 3x to the 4th. $16. 5 goes into 15 3 times, 25 5 times, And then all the rest are negatives. So we're moving top to bottom and bottom to top. So 3 stays in the numerator, 5 stays in the denominator. The a to the 5th is going to move to the bottom. The b to the 1st is going to move to the bottom. The a to the -2 is going to move to the top as a squared. And b to the 4th is not negative. B to the 4th is going to stay in the denominator. So I end up with 3a squared over 5a to the 5th, b to the 5th. And then because both of these have the same base, I would subtract the 5 minus 2, keeping it where the exponent was larger. So it's 3 over 5a to the 3rd, b to the 5th. And the last slide. Now we've got exponents on the outside. So remember, you have 2 choices. Distribute them individually or flip and then move. I'm going to show you one of each method. So I'm going to start with 17, where we're going to distribute the -2 to each term. So I end up with -3 to the -2, a to the -2, b to the -2, over 4 to the -2, so a -3 multiplied by a -2 is a +6. And then b, 4 times a -2, -8. Now this -3 is also in parentheses because it was inside the parentheses here. So that's important because the negative has to stay inside the parentheses. Now everything with a negative exponent, we're going to move. So 5 of these 6 elements are going to move. So I'm going to leave, I'm just going to draw the line. I'm going to bring the -2 to the second to the bottom, the a to the second to the bottom, and the b to the second in the bottom. The 4 to the -2 brings the 4 squared to the top. A to the 6th is going to stay in the bottom, and b to the -8 brings b to the 8 to the top. Now I have 16, b to the 8, over -3 times -3, which is 9. A squared, and a to the 6th is a to the 8th, b squared. Nothing goes into both 16 and 9, so the coefficients are going to stay. But this b to the 2nd can come off of the b to the 8 in the numerator, and I end up with 16 b to the 6th over 9 a to the 8th. All right, now 18, we're going to do the other way. What we're going to do with this one is, because there's a negative on the outside, we're going to flip everything on the inside. Now, be careful. The flip of that does not get rid of the negative on the inside. It only eliminates the negative on the outside. So this is where it gets kind of confusing. So I'm flipping the inside but keeping all of the signs. 9xz to the -1 over -3xy to the -2. The outside became positive. So again, it can't be both inside and outside becoming positive, just one when you flip. Now I'm going to distribute to each term on the, well, actually now I'm going to simplify, the -3 and the 9. -3 would go into itself once, and 9 into 9 3 times. So I've got 3xz to the -1st over -xy to the -2, all raised to the 3rd power. Now I can also simplify out the x's from here, and that's one less step for later, or you can distribute and then simplify. So it doesn't matter when you do this, but if I distribute the 3 in, so 3 to the 3rd is 27. Distribute the 3 in, x to the 3rd. Distribute the 3 in, z to the -3rd. Negative x raised to the 3rd. So it would be negative x to the third, and y to the negative 2 raised to the third, y to the negative 6th. Now the x to the third's still canceled. There's a negative in the bottom, so that's still a negative 27. The z is going to go to the bottom, so z to the third, and the y is going to come to the top, y to the 6th. So you could have done it the same way we did it the first time, which was distribute that negative 3 out to all of them, move what's negative, and then simplify it. In the beginning here, you could have also canceled your x's from the get-go and saved that step, so it doesn't matter when you do that, as long as you simplify it at some point. All right, that wraps up the negative exponent part of P2. You're going to take the time to submit your notes so that you can get an easy 100 grade. Has to be before the end of the class period. And then you can start your homework. Now in the P.2b homework, there's also square roots or fractional exponents. So if you saw something that said like 2 to the 2/3, skip it for tonight. We'll get to those on Monday. So based on what we learned today, you can complete numbers 1 through 10. And then you'll finish the rest of that for Monday evening's homework, and it will actually be due on Tuesday. So notes, due now. Homework will be due Tuesday, but you want to start it so that it's not so much for Monday night. You can do numbers 1 through 10. Have a great weekend, guys, and I will see you Monday.